Hello everyone, and welcome back to the ACE Labs tutorial series on extended reality, immersive analytics, application development in Unity. As always, my name is Bryson, and in this third video in the series, we will be delving into Unity and starting to build a simple XR application using the various MRTK pre-built assets and scripts we just learned about in the last video. Now, this video will be part one of a few, over which we will continue to develop this example application. In doing so, we will learn how quick and easy it is to tie in and utilize MRTK in any application to help facilitate intuitive user experience and interaction in AR and VR. Specifically in this video, we will be focusing on three main things. First, the initial setup of MRTK and its settings in a scene. Secondly, how to add and use the bounce control and object manipulator components on a GameObject to allow for intuitive manipulation of it in XR. And thirdly, how to implement different types of pre-built MRTK buttons to quick and easily tie in basic UI-based interactions with GameObjects in our scene. Now, I highly recommend that you follow along in Unity yourself with these videos so that you can best learn what we will be doing through hands-on experience. Thus, if you'd like to follow along, then I'd encourage you to pause the video here and open up a new Unity project on your end with MRTK installed in it before continuing. If you do not yet have MRTK set up with a Unity project, then I will direct you to the first video in this series that will walk you through that process. All right, so let's jump into it. Starting off, we have ourselves a new empty scene here, and I've just called this your project name main scene, so feel free to add the name of your project in place of your project name here. And so our first step is to get MRTK added to the scene. Now, as you'll recall, we added MRTK to the Unity project, and you can see evidence of that by the entry of mixed reality on the toolbar up here. However, this does not mean that when you create a new scene in this project that MRTK is able to be used in that scene automatically, as in some cases you may want some scenes to have MRTK in it and other scenes to not. And so what we need to do is we need to add MRTK to this scene explicitly. And to do that, it's very simple. All you need to do is simply go up to the mixed reality button on the toolbar up here and go down to Toolkit, and you'll see an option for Add to Scene and Configure. And by clicking on this, it will add MRTK's capabilities to that scene. Very simple, nice and quick and easy. And you'll see that it added three game objects here inside the hierarchy. The first is the mixed reality toolkit. Now, that simply adds a game object that handles all of the settings for your scene regarding the mixed reality toolkit and how it works with all of your game objects within the scene. So as we saw in the last video, this is where the profiles are that we can pick a profile for that handles all these settings. And these settings involve things such as how MRTK should handle the camera, the input boundary, teleportation, diagnostics, etc. And so this game object is where that is all handled. So if you need to change any MRTK settings during runtime, this mixed reality toolkit game object is where you go to access them. Now, our next game object here is the mixed reality play space. And this is just for holding the game objects that MRTK creates for its functionalities during runtime so that it doesn't interfere with the rest of the hierarchy and your game objects within the rest of the project. So for example, here is where the boundaries regarding your play space will get created under. The hands that come up during input simulation when you're running things within the Unity editor, they will be created under here. And you will notice that the main camera is also under here with a couple different additional scripts added onto it. Now, it is very important that you keep the main camera here and that there is no other cameras acting as your main camera in your scene, as MRTK relies on the main camera being in this exact position with these scripts on it, so make sure not to mess with any of this and that you don't have any cameras interfering with it. And our third game object here is the mixed reality scene content game object. Now, this essentially just houses a script that allows us to easily align the game objects that are the children of this game object with either the user's head height or the experience scale. And what the experience scale is essentially regarding the experience settings here in MRTK. We can either target experiences that are of room scale or world scale, like for some AR applications you might want, or standing scale or for sitting scale. Like if you wanted to create a mixed reality application that is targeting mixing things with a computer monitors on a desk and the person will be sitting the entire time, you can have different experience scales for that and an offset from the origin of that scale. So for example, room scales, you'll see here that the origin for the world is on the floor facing forward from where the headset was initialized. And so essentially what this mixed reality scene context will do is it will make sure that any game objects that are the child of this are aligned according to your settings there. So that you don't need to make sure that certain elements are lined up with the ground properly or with the user's head properly. This mixed reality scene context script will essentially help you not have to worry about aligning things exactly how they should be as much. Now, you don't necessarily need to rely on this game object itself for that. There's also this container object, which basically gives you the option to slide in another game object here, and it will align that game object and the children of that game object with the experience scale and the head height instead of the game objects that are tied to this game object. So now that we've gone through these new game objects that were added, our next step that's really important that we do before we start making anything within our Unity scene is to head back to the Mixed Reality Toolkit script here and adjust our settings so as to make sure that all of our settings are exactly how we want it for our project and targeting the device that we want to target. So expanding things a bit, you'll notice here that all of these options here are grayed out and we're not able to adjust them. And this is due to the fact that, as you'll see here, Mixed Reality Toolkit's core profiles are used for getting things up and running properly. However, you're not able to modify them. And so if you want to adjust any of these, you need to make a custom profile for your application. So you can either do this by creating a new profile and selecting everything from scratch, or what I would recommend is finding a configuration profile that best fits your application within one of these, and then simply cloning it and customizing it to your needs. So we'll do that. In most cases, probably the default Mixed Reality Toolkit configuration profile is a good starting point for fitting your application's needs. If you're doing a HoloLens 1 or 2, these ones will be better. But for the purposes of these tutorials, I will be using the default Mixed Reality Toolkit configuration profile in order to cover the most general case across everyone's needs. So simply to clone it, we go to Copy and Customize, and it'll bring up a little menu here. And all we need to do is simply just write a new name for this. So do for project name, MRTK configuration profile, and simply click clone. And now, as you'll see here, those messages went away and we can actually go in and start modifying a bunch of the options here. However, you'll notice that some of these are grayed out still, and that is because there are sub profiles for many of these menus that if you want to customize these submenus, you will also need to create clones of the profiles for these. So I won't go through each of these and create a custom profile for them, but to give you an example here, let's just go to boundary here. And if you remember back to the first video, when we deployed onto our VR headset, we had that green and blue floor that was coming up. And this is what's responsible for that, is these are toggled on to show. However, we might want to turn those off as they're a bit of an eyesore. So to simply do that, all we do is come to this profile here and select clone. And then we just select a new name for it. So let's just call this your project name MRTK boundary visualization profile and click clone. And now we are able to adjust the settings in here, and we can turn all these off. And now when we deploy to our headset, those should no longer be showing. Some of the other submenus we should look at are the teleportation system to make sure that we're able to teleport around in VR. However, if you're running AR, you'll want to turn this off. On the flip side, if you are running things in VR and don't want a spatial awareness system, for example, if you're running a headset that can't do that, we simply want to toggle this off here. And if at any point during development, if that diagnostic menu that's coming up is a bit annoying and getting in your face and you just want to turn it off completely, we can simply just disable that here, which we will do for the remainder of this video. So now that we've adjusted our settings for the bottom 4 submenus here, let's head up to the top 3, which some would argue are the most important. Under experience settings, we have some options here regarding what experience scale we want. In the majority of cases, if you're doing an application where you want the user to be free to move about the room in some predefined play space, you'd want to click the room option here, and this is what we'll be using for this tutorial series. However, we have some options for if you have an application where the user is stationary and seated, if they are stationary and standing and can only just rotate around, or if you are doing some sort of application with either spatial mapping or spatial anchors, such as with the HoloLens 2, you would want to use this experience scale here. But we'll just be using the room experience scale for our application, but feel free to select the one that fits your application the best. Regarding our camera settings, the default settings that we have here are actually sufficient for the majority of applications, and so we're just going to keep this the same, and you can feel free to do so as well. However, if in the future you ever need to modify the clipping planes here or the quality of your camera, you can do that down there. And then over in our input system settings, these are also sufficient for the majority of applications. The only difference is if you're running, let's say, the HoloLens 1 or 2, you would have different system settings here, and that's just because you cloned a different configuration profile. But in the case of, let's say, VR applications, the default ones here are likely sufficient for your application and are sufficient for the majority of cases. So for the purpose of these tutorial videos, we'll be keeping these the same. However, just to note of what's available to you, there are some options for changing how the hand tracking looks to the users, adding more speech commands. So if you want certain words to do certain actions, you can do that in here. Adding new gestures to do new commands, you can do that there, as well as customizing what the controllers look like for different applications, or when you deploy to different devices, their controllers can look different. Or if you want to customize the pointer that's coming off of the controller, you can do some customization in here and also enable your eye tracking through this option here. So there's a bunch of options available to us. However, the default settings that they have it right now are sufficient for our purposes and are likely sufficient for yours. So we will keep things the same. So now that we've gone through and made sure all of our settings are how we want them for MRTK for our project, let's head into our scene and start developing our application. All right, so our first order of business is to add an object to interact with within our scene. To keep things simple, we'll be starting off with just a basic cube here. However, think of this as an abstract representation for any game object within your extended reality application. So for example, this could be a UI element or a 3D model within your scene, or in the case of immersive analytics applications where we have a lot of data visualizations, this could be anything from a 2D data panel, chart, or graph to 3D objects like 3D models, maps, graphs, or volumes. Since all these options clearly vary quite a lot from one another, and we haven't yet learned how to create data visualizations within Unity, to keep things simple and general across the variety of immersive analytics applications you might all wish to make, we'll be using just simple models like this cube for the time being to abstractly represent such objects. So now that we have this cube in our scene, we can go over to play mode here. And we can see that MRTK is up and running with its input simulation system. However, note that we cannot grab and move this cube around our scene. Now, this makes sense as we haven't added anything onto it to allow us to do that. So going back, as we learned about in the last video, there's two things we can add on to GameObjects within our scene to allow us to do this. The first being bounds control, and the second being object manipulator. So let's start by adding the first one here. So to do so, we simply go to the GameObject and add component, and go and add bounce control, and that's pretty much it. Simply just add it as a component on the GameObject, and if we run things within our scene again, we can see that there's now those little handles added on to the sides there, and we can grab them and move the object within our scene. So let's grab this. We can now rotate and scale. And as noted last time, you can even add translation handles. To do so, we simply go down to here to the translation handles configuration and check these boxes here. And by going back into our scene, you will now see that at the center of each of the sides of the bounds, there's a little node here for translating the object within our scene. Now you may notice that everything is gray currently within our scene, and that is just because the material that is applied to our bounding box as well as our cube is currently gray. So let's go and add some nice looking materials onto those quickly. So let's go to whatever your project name is, and let's add a folder here. All materials. And let's create some materials here. And let's just keep them universal lit, just nice and simple, but let's make the visualization a nice orange here. And let's rename this to abstract object material. And in the case of our handles that are on our bounding box, let's do the same. So we can either create new materials by doing the same thing of going into the create options here and adding material, or we can duplicate this material, which might save us some time. So to do this, you'll note that when you right click on things, it doesn't give you a duplicate option, but to get past that, we can simply just go over to edit, and you'll see a duplicate option there, and that is where we can duplicate things. So let's duplicate things, change this to bounds control handle material. And let's duplicate this again, which you can also just do simply with Control D if you want. And let's rename this to bounds control line material. And you'll see why I created two in a second here. So before we pick some colors, let's go back to the cube here and let's apply our material. And now you can see it's a nice orange. And with our bounds control, you'll see that when we go into the visual section here, that there is some materials missing for the handles as well as the links here. And so all we need to do is simply just drag those on to our object here. And you can have different materials here for when it's grabbed versus when it's not grabbed, which can be quite handy, as well as custom prefabs and changing the sizing. Completely up to you and how you'd like to have things. And since we added those translation handles, let's add some onto there as well. And then with those lines that are in between all the handles here on the bounds of the object, that is what links are. And so that's why we made the second one, is for those lines. And so let's simply add another material here, and let's pick some colors for them. So for the handles here, let's make a nice blue, let's say. Yeah, that looks nice. And then for the links, let's just have them as a good white. And now when we play within our scene, you'll see here that we now have everything all colored and looking much nicer than they did before, and everything works properly how it should. Now, the last thing we maybe might want to do is up the scales of the handles just because they're a little bit small to grab. So let's just up these by, let's just double the scale of all these to make them a little bit nicer. So you can simply go into each of these, change the handle size that you would like. And when we head back in, we can see that the handles are now nicely doubled in size and much easier to grab. Okay, so now that we've added the bounce control to our object here, one thing to note is that to translate it around the scene, we currently can't grab any point on the object. We have to grab these points on the object, and as you can see, it only moves along one axis, so it's not very fluid if we simply just wanted to drag and move an object, let's say from here over to there. So to do this, we add our second script that we learned about to our game object, and that is Object Manipulator. So to do that, we simply just add the component Object Manipulator onto the object here, and you'll see a little warning comes up saying it doesn't have near interaction support. This is mainly just for when you get nice and close to objects versus far away when using that fission line. So usually it's recommended to just click on that and add near interaction support, and that will add another component onto this game object. But as we can see now, simply by adding this component onto the game object, we can now not only use those handles for fine movement of our object, but we can now grab and fluidly move our object around the scene in a very natural way, as well as if we do two-handed grabbing, we can scale our object and rotate it and move it around as we would like. So very nice. Now we have a way to grab and move objects about within our scene. It's as simple as that. So now that we have some ways to directly interact with our game object, let's add some ways to indirectly interact with it via MRTK 3D UI. Now, to access the pre-built prefabs that MRTK has made for us, we can either go and search for them inside of all the MRTK folders and stuff down here. However, a much more easy way to access them, at least for the more basic everyday elements, is through this mixed reality entry up here. We can go to Toolkit and click on Toolbox, and it will bring us to a menu with all of MRTK's buttons, button collections, near menus, some miscellaneous tooltips, other things and stuff here. And I usually like to drag this down to the bottom here to have quick and easy access to them, and we can start adding them into our scene. So let's start by just adding a simple button, and we can do this by simply just clicking on this button here, and you'll see that it gets added into our scene. And if we press play and float around here, we can see that it is spawned right in front of us, and we can use the input simulator to click on the button inside of our scene. Now, to keep this nice and organized, let's tie this into a backplate here, which is simply just a backdrop that supplies a visual anchor for our UI, so it's not just floating in space. And let's give it some functionality. So if we go to the button here, we can see that there is some options here. Now you'll notice that it has a pressable button HoloLens 2 script on it, as well as a interactable. When you want to tie in stuff to the button itself, go to the interactable script, as these events essentially just get routed via this event router to interactable. And so make sure you're adding things onto here. But inside interactable, which we'll go into more depth in the next video, we can see that under events here, we have some options for calling an event when we click on the button, as well as some other receivers to animate the button when we place focus on it and remove our focus from it. And so now what we're going to do is look at how we can tie in functions we write to UI elements that have the interactable script on them, such as these buttons, so that when we click on them or interact with them in some way, it will fire off our desired function and do some action for us. But to do this, we first need to write a script that has our desired function in it. And so let's go back into our project and create a new folder called scripts. And let's create a new script called, we'll just have one script that handles all of this UI that we're going to be adding to our scene. And so let's go to our script and call it scene UI handler. Now that our script is open for us, we can start by getting rid of start and update, as we don't need those, at least not right now, and can always add those later. However, what we need here is a function that we want to tie into our button. So to keep things simple, let's start off by having our first button here simply toggle on and off the object. And to do this, we just add a simple function, which let's just call toggle object. And one big thing to note is make sure that this is public, or else when you're trying to tie into the button, the interactable script won't be able to find it. And to simply toggle a game object, we need a reference to it. And you could either pass that into the function. However, the first way that many people might want to do that is to have a public reference that we tie in via the inspector somewhere. And so let's do that first. And simply inside this function, we can check for the current state of the visualization by simply calling active self. So if it's on, this will be true. If the game object is off, this will be false. And we can then use the inverse of this to set the set active function. And what this will do is essentially set the state of the game object. So with this, if it's on, we'll pass false into this and it will turn it off. And if it is off, we'll pass true into this and it will turn it on. Easy as that. So now let's head back to Unity and take a look at our button that we want to add this function to. So you'll notice here that onClick requires a reference to a game object, and this will be the game object that we have our desired script on as a component. So let's add our scene UI handler onto a game object here. Now, since it's going to be a global handler of all scene UI for the case of this scene, we could add it to scene content, for example, or add it to another game object. For our cases, we're going to just have it as its own game object, as it's nice to keep it nice and separate and not mixed with other things. And so let's just add this here. Let's bring it up to the top so it's above everything else. And let's adjust this to be placed at the origin. Now this is arbitrary as we don't have a physical component on this game object. However, it's just good convention to place your global managers and handlers in an organized manner and not just have them be randomly placed around in your scene. And so let's add the scene UI handler here, and let's provide the reference to our abstract data visualization, which is just our cube. And ta-da, now that's all set up. Now, if we go back to our button here and scroll down, we can now grab the reference to our scene UI handler, bring that to there, and go into our script for scene UI handler and bring us down to toggle object. And now we have that all connected to the button. And so if we now play and go into the scene here, we can see that our button is now able to toggle on and off our game object in our scene. So the other way we could do this is to not use a reference to cube at all in this scene UI handler, and instead provide the reference just right inside of here. And the benefit to this is we can have a general toggle object script that can be any game object that we feed it that game object inside of the interactable here, and it will toggle it on and off. It really depends on the case of what you would like your script for, but regardless, this is a really easy change. Simply all we need to do is just provide the game object, and let's call this game object to toggle, and switch these out, get rid of our reference here, and now we have that all switched out. And if we head back into our Unity project and go back to our scene UI handler, we'll see that that reference is gone. And inside of our button, you'll notice that the reference to the function broke, and that's because we adjusted the function and changed it a bit. So if we go and link this back together, we'll see that now we have a place here to provide the input to toggle object here. And so if we just grab our cube and drag it here, then we have the exact same functionality as we had previously, where the button is able to toggle the game object on and off. And now not only do we have a function that is able to toggle on and off this game object, but this is a general function that can be used to toggle on and off any game object provided the input, which we can also tie to other UI elements as well in the future potentially. So before we move on, let's do a little bit of cleanup here. The first thing we're going to do is just rename this cube here to being abstract data viz to more clearly represent what that cube is supposed to represent. And you'll see that that is now changed in everywhere that it is referenced to as well, so you don't need to worry about that accidentally disconnecting anything. And the next thing is that since we're going to be using this backplate as an anchor for our UI, let's actually have it act as the parent of this button here. And so let's just drag that onto there. And last thing is that this button actually should have an outline. And the reason for that is it's just a little bit further back. So if we grab it and move it forward on its axis, we can see that now that outline has popped through. So now that we have our first button sorted out, the next UI element that we're going to add is something to toggle a component of a game object. And in the case that we're going to be doing today is we're actually going to be adding a toggle switch to toggle on and off the bounce control script, because sometimes you may not want those handles visually around your data visualization, and other times you would want them there in order to interact with it. So to do this, we first need to find that toggle switch. So let's go back to the MRTK toolbox here. And if we scroll around a little bit, we'll see if we go up to the buttons, there's a whole bunch of buttons that we have access to, but there is in fact a pre-built generic toggle switch that MRTK has ready for us. So if we click on this, it comes up right here. You'll see that's quite large. So we will shrink it down to be about half that size. And now let's make this a child of our backplate. And let's move our button up a little bit and our toggle switch down so that they are no longer overlapping each other. And in order to tie in the toggling of our bounds control script to this toggle switch, we could do the same thing that we did with the button and create our own custom script for it. However, since we are basically just telling the script to toggle on and off, and the enabling and disabling of a component is handled by a variable that can be accessed publicly, we actually don't need to write a script at all. So if we go over to the toggle switch here and scroll down to how we were doing things previously, we could simply use the onClick function here. However, we might want to separate the functionalities between when the switch is toggled on and when it's toggled off. And so to not just simply rely on just on-click events, but separate this out, we can use our own custom event receiver. And so if we go to add event here and look at all our options here, we see that we can add another on-click receiver, such as up here, or on focus, grab, hold, press, toggle, and touch. And in our case, since we want to handle one case when it's toggled on and one case when it's toggled off, we will use the on toggle receiver here. And so you'll see our two options here for select when it's on, deselect when it's off. And let's go and add some functions to trigger when these events are called. So since we want to toggle on and off the bounds control component that is on our abstract data viz, let's grab our abstract data viz from up here. And if we go into finding our function here, we can actually go directly to the bounds control script, and we'll see that we have access to all of the various public variables that bounds control has. And you'll see that there's this Boolean for enabled. And this handles if the component is on or off on the game object. So if we just click on this Boolean here, we can see that we can actually set this Boolean when onSelect is called. And so if this onSelect is on initially, we might want to make sure that bounds control is enabled. However, if the toggle switch is off, we might want to make sure that it is not enabled. And if we simply play, now that we have that all tied in here, we see that when we click on this toggle switch, it is on initially even though it says off. And that's something that we can easily fix. But simply when we toggle the switch on, the bounds is on, and when we toggle it off, the bounds are off. And we can still interact with it via the object manipulator script. However, there's no handles for that fine transform manipulation. But if we have the toggle back on here, we now have the handles back, allowing us to rotate in a constrained manner. And so simply when we head back, we note that our switch is toggled off initially. And so simply by just going up here, we can just click this box here is toggled, and that will make sure that on start it is toggled on initially. And so that would fix that issue. And the other issue is that we see that when we toggle things on and off, the text doesn't change. And that text is simply just inside the content here, the button content under label. And we can see that our interactable on the toggle switch doesn't actually change anything regarding the label. And so we can set that up ourselves. And it's as simple as simply just adding two more functions to tie in here, grabbing our label, dragging it into these sections here, going into them, finding our text mesh here, and going down to our text string and making sure that when it is selected, the label says that it's on, and when it is deselected, the label says that it's off. And the last thing we need to do is, now that we have is toggled being the state that this toggle switch is in initially, we need to go back to our label and change it to being on, because that is the state that it should start with. And now if we head back into play mode here, we can see that our switch is now initially on. It says that it is on, And when we click on it, it toggles off. And when we click on it again, it toggles on. Very nice. All right, so the next thing that we're going to do is add some buttons that allow us to switch the mesh of our game object. Now, this could represent changing between different data visualizations or different filtered views of data visualizations. And so it could be any number of functionalities, but in the case of how we have things right now, we will be switching the mesh. So to do this, let's get some radio buttons in here. So the first thing we're going to do is go up again to our buttons in MRTK, and you'll see here that we have an option for generic radio set. And so clicking on this, you'll see that we have a couple of radial buttons here that get added to our scene. And so let's make these a little bit smaller. And bring these over here, and then let's expand this backplate a bit. So if we're to expand our backplate here, we have a little bit of a problem. The issue is that since we tied in our pressable button and toggle switch to move with the backplate, it does that nicely. However, if we want to expand this backplate at all, we see that the scale causes things to stretch, even though our backplate remains how we want it to be. So to fix this, we actually have to parent it to something different. Now, a good candidate for this is actually the scene UI handler, as that is handling things anyways and doesn't have any graphical elements on it itself. So let's drag this up to being on the scene UI handler, and let's bring these pressable buttons off of it onto the scene UI handler here. And now we have that fixed, simple as that. So now this moves together with everything, but now we can actually go to our backplate and expand that without creating issues with everything else. And so let's just make it that size there. And now we have those radio buttons on there. And since we're using this to switch between different meshes, let's go to our radial set. Let's drag this onto our scene UI handler. And we see that we have 3 different radio buttons, each with their interactable on it. And so we know immediately that in order to tie this into switching meshes, we simply just go down to this events section here and do just as we did for this button and this button. And you might immediately think, well, if we're just changing the mesh on a button, why don't we do it like how we did with this button, where we simply just go to add event. We would scroll down to on click and then add an event that simply grabs the abstract data viz, goes to the mesh filter and changes the mesh. And we don't need to write a custom script if we do it this way. Now, this is a perfectly valid way to do this. So if we did this to each of these buttons, they would each have a different mesh on them, so that when we clicked on the buttons, it would switch to that different mesh. However, the issue with this is that meshes come in all sorts of shapes and sizes. So for example, if we go to our abstract data viz here and go and look at some of the different meshes, we can see that the capsule is a little bit taller. If we go to the hammer, we see that it's really small. And if we look through a whole bunch of the hidden stuff here, we'll see that we have all sorts of meshes here that come in various shapes and sizes. So if we want to keep things the same size or relatively same size, we face an issue where if we simply just change the mesh, it's going to not change the size, and thus we'd have some looking how they should be, some a lot larger than they should be, and some being a lot smaller. So your next inclination would go, okay, well, if we need to change values on the transform, when we click on things, we can simply just add another on-click event here drag in our abstract data viz, and simply go to the transform and modify the scale that way. However, if you look here, you'll see that you cannot directly modify the translation, rotation, and scale via your access to functions here. And so what this really forces us to do is create a script that does this ourselves, where our script allows us to switch to a mesh and a corresponding scale at the same time. So let's take these events off here and let's actually go back into our scene UI handler script and add the appropriate functions here. So your initial inclination might be to create a function that takes in two parameters. Let's just call this switch mesh, which takes in a mesh and a vector 3, which is your scale vector. And to apply this to our abstract data visualization, we would need a reference to that. And so let's go back up to the top here and re-add that to the top. And going back down here, all we do is simply just say abstract data viz dot get component mesh filter dot mesh equals our mesh that we pass in here. And similarly, we have abstract data viz dot the transform of the abstract data viz GameObject dot local scale is equal to scale vector. However, there's one issue, and that is that if we're tying this into an interactable script, the only way to tie in functions to an interactable script is if that function only has 0 or 1 input parameters. And this one has 2. And so you'll see that if we go back to Unity and go to our interactable on these radio buttons to add our own on click event for these, you'll see that if we drag in our scene UI handler and try to access the switch mesh script we just made, that we can't see it here. And that is because it is 2 input parameters. And to prove this, if we simply just go back and get rid of one of these, we'll now see that the interactable now gives us access to the switch mesh script, but we no longer are able to apply a scaling factor here. So we need to get a little creative. There's a couple of ways we could do this. The first is to create separate functions, one that changes the scale, one that changes the mesh. But if we are wanting to keep things a bit more organized and centralized and not spread across the buttons, let's instead use a custom function in Scene UI Handler that utilizes our own list of mesh scale vector pairs that we can easily set and change in the inspector. And so we're going to head back to our Scene UI handler, and instead of a mesh itself, we're going to take in a index of a mesh scale pair. And we're going to go up here and create a struct called mesh scale pair that is simply just a mesh and a scale vector. And we're going to then create a public list of these. And you may be inclined to use a tuple here, or a tuple. However, the issue with doing that is those will not come up in the inspector. So if we want to apply these mesh scale pairs in the inspector, we need to be able to see them in the inspector, and tuples won't easily come up. In fact, We head back to our Unity here. We'll see that the list doesn't come up at all. And this is because, just like tuples, our struct is not automatically supported by the Unity serializer. However, we can easily fix this by simply going back to our script and adding serializable above our struct. And if we now go back, we'll now see that we now can access the mesh scale list. And so let's add 3 meshes here. So the first we'll keep as our cube and just have a scale of 1, 1, 1. The second, let's pick something interesting. Let's just do this hammer here. And what's some good scale for it? Let's put our scale for that as 555. And for our third, let's go to engines and maybe a nice 10, 10, 10 will look good. Sure. All right, so let's just revert this back to cube and head back over to our scene UI handler. And so let's just do cube with a scale of 1, 1, 1, hammer with a scale of 5, 5, 5, and engines with a scale of 10, 10, 10. And we still need to apply our abstract data viz object, so let's go and put that there. And then if we go back to scene UI handler, now we need to tie in our list of mesh scale pairs that we want to the function that will be on our 3 buttons. And so remember that we added our mesh scale pair index here. And what this will do is it will grab the element of this mesh scale list and set that to our get component and local scale. So all we need to do here is simply just do mesh scale pair list, pair index dot mesh, scale vector. Now that's all done. And if we go back into our radial buttons, let's change the text on them to actually match what objects we're setting them to. So our first one, let's have it just be that standard cube. The second one, let's have that be our hammer. And for our third one, let's have that be our engines. And let's minimize this down a little bit. In fact, we can probably make a little smaller. And now the last thing we need to do is simply just tie in this to the interactable. And so since our cube will be the initial state of the visualization first, let's make sure that this radial is toggled on initially. And let's go down to our onClick event here and find our switch mesh option. And it will be the 0th element in the scene scale list. And let's do the same to the other 2. This will be the first element in that list. And for the last one, let's go and add that to being number 2. And yeah, now we have that all set up to switch the mesh around. So yeah, so if we go in, we'll see that we now have options for our cube and engines and everything. And we will go in and click on hammer and oh, it looks like we have a bit of an issue here. So when we applied the scale to the GameObject, it scaled up the box collider that is applied to bounds control. And so you'll see that the box collider scaled up dramatically. And that's not a big issue. This is actually a relatively easy fix. So how to adjust this is simply just go back into our script here. And since we're going to be needing to access the mesh a couple times, let's put this in its own variable. So at the top here, let's just go mesh, new mesh is equal to this element here. And then let's pop down, and we'll need to be grabbing the box collider from here. So we'll just do box collider. We'll just call this data viz box collider is equal to extract data viz get component box collider. Okay, so here all we need to do is simply update the size of the box collider to be the new meshes dot bounds dot size, and do the same thing with the center of the box collider. And if we simply ran the code here, we would see that the box collider would update, but the bounds control would not update. And so to make sure that the bounds control updates, all we need to do here is just do dataviz.get component bounds control, and you'll see that it doesn't recognize it, so we just need to add bounds control here, and then just do update bounds. And actually, this isn't necessary. We'll just get rid of that. Now, if we head back, we can see that when we run things, that now our bounds for our objects updates and wraps around our objects. We can, just like before, grab and rotate and scale our objects how we would like. Perfect. Very nice. All right, so now that we have learned the basics of how to use single state buttons, buttons with two states like the toggle switches, and button groups, and in the case we implemented a group where the buttons affect one another by turning the others off when you turn one on, we now have what it takes to essentially implement any style of pre-built button that MRTK has for us. So if we go down and take a look at the MRTK toolbox again, we now pretty much know how to implement all of these other pre-built buttons and button groups, as all of them are simply based around the same use of interactable. And this includes not only the buttons up here in the button section, but also the collections of buttons, the near menus, as these are also just collections of individual buttons, and even the app bar down here in the miscellaneous section too. So with this knowledge, you now should be able to effectively implement any MRTK button you'd like with ease. Not only this, but if we take a look at the clip which played at the start of this video, we see that the buttons used there are not pre-built MRTK buttons, but custom buttons made specifically for that project. Now, they may look quite different visually, but actually the setup of these custom buttons is pretty much identical to the buttons we just implemented, as these are also simply based around an interactable component that is on each of them. Now, to fully set up such custom buttons, we need to first learn a few more things about the interactable component, which we shall be covering in a coming video. But I hope that this knowledge gives you a taste of how what we just learned can also be used to help make custom UI elements yourself with MRTK's help. All right, so we'll wrap things up for this video here, but I hope that now you have a good idea of how to set up MRTK in your desired profile settings in a scene, the basics of applying bounds control and object manipulator to desired game objects to give users the ability to intuitively manipulate them, as well as how to get MRTK buttons quickly and easily in your scene to provide users a simple method of UI-based XR interaction with GameObjects without much work. Admittedly, in trying to keep these videos not any longer, I can only touch on the basics of each of these, and so I encourage you to take a look yourself at the bounds control, object manipulator, and interactable components a bit closer on your own time, play around with each of them, and check out their documentation to get a full view of all of the options available to you with them. In fact, MRTK's hand interaction example scene that we were using in the first video is a good place to see and play around with some of the possibilities available to you with combining these three scripts. But with that, without further ado, we will end things here. So as always, thank you for watching. Hope you learned something. Watch for bears and jackal wares, and I'll see you in the next video.